Okay, folks. Right. According to the power of the internet, it is apparently now 9 o'clock. So, okay. Good morning. See? Responsive. That's what we want in an architecture. So you may be aware that Britain's been going through some social upheaval in recent years. This is some of our latest architecture. And so what I want to talk about is refactoring. I want to talk about the fact that it's not just a shortcut key. Many people think of it in those terms ever since it got integrated into IDEs. But refactoring has a longer history, and it also has a different story, a story that is rooted in design and design thinking. So the reason this is here is not merely social commentary and political satire. It is the observation that many of us deal with legacy code. In fact, you spend most of your time programming in the past. Okay, you think you're in technology, and therefore everybody in your family thinks not only can you fix their computer, but you're on the leading edge. But you spend most of your time programming in the past. The languages you use, they were either developed last century or at the beginning of this century, statistically speaking. There are a few of you who are using languages that were actually invented in the last decade, but you're in a relative minority. Most of what you are doing is in the past. You sit down, you write a piece of code. It is very unlikely that that code remains in the present. Most of your code is written against something that was written yesterday, last week, last month, last year. You are programming in the past. In an 8-hour day, you spend 7 to 7.5 hours working in the past, dealing with the consequences of what was there. So for an industry that is focused on the future, we're really pretty crap at it. So surely refactoring solved these problems. That's what I want to deal with. But why is it we end up with stuff like this, legacy systems? Here we have a legacy system. Apparently it's a rather large astronomical clock. We don't know who built it. We don't know why they built it. But twice a year it works. Now sometimes it's not just that. Sometimes there's another side to developers. Oh, we love complexity. We can look at somebody says, here, I have a simple requirement. And it seems that many developers look at the simple requirement and go, you know what? I can make that harder. I just heard, wait a minute, in the last 5 minutes, yes, there's a new JavaScript framework. Let's use that. Okay? So we have an innate technical joy. And the point is, I'm not saying that's a bad thing. It's actually what got many of us involved or interested in software. But we will need to recognize that every good thing has another side to it. The very fact that you enjoy kind of puzzles, solving, expressing solutions, working with these things, and that joy of getting something working sometimes has this side effect that you do exactly that when it's not necessary. Now, many people talk about this in terms of technical debt. Technical debt is a widely misunderstood metaphor. A lot of people use technical debt just to mean bad. The whole point is, let me just remind you, the debt metaphor is supposed to tell you that you can have debt, and it can be good or bad. Technical debt is not a bad thing. When I hear people say, oh, we have technical debt. Okay, so what? I have debt as well. The question is not do you have it, is do you manage it? The thing I want to hear from people is not we have lots of technical debt. It's whether or not they have managed or unmanaged technical debt. That's the extra word that's really important. If you have managed technical debt, that is not a problem. Well done. You're doing the right thing. That's the whole point of debt, to get an advantage through accruing a debt that you can then responsibly repay. However, most people have a really bad experience with debt, both in code and in the real world. So they short-circuit it to mean bad, but that's not the full metaphor. And if you ever have a dashboard that tells you your debt value in krona, euros, dollars, or whatever, I won't choose pounds because pounds are really not worth very much these days. But I'm really glad my expenses are being paid in krona. I'm winning, you know. In the month since I bought my flights, I am actually earning a profit. If you have that on your dashboard, that's bad science. That's false numbers. You cannot turn technical debt into a numerical currency value. If you're not sure why, that's a separate talk, and I'm happy to have it as a conversation. But it's actually If you think, no, but we have it, no, it's against the laws of physics and mathematics. So if you think you have it, you don't. But it is a useful thing. But I don't want to talk about the debt side of things. I want to talk about how we got there. This is a term I started using recently, as in last week. I found myself talking to a client, and I suddenly realized we keep focusing on a consequence, but not the cause. Technical debt is not a cause of technical debt of itself. There are many things. One, our innate desire for complexity. One, the blind eye that we turn to things. That's called neglect. Okay, we have parallel. Instead of looking to economics, we need to look at psychology, physical neglect, emotional neglect, things like that. Technical neglect is the problem that we suffer in Codebase. It's not technical debt. Technical debt is the effect. What is the cause? Technical neglect. So this leads us to refactoring. And yeah, you got to quote either XKCD or commit strip. So today I'm doing commit strip. If you've not come across commit strip, that's your homework. Okay, a couple of guys in Belgium do this. It's fantastic. So will refactor, the manager on the left, will refactoring the code improve the loading time? Developer on the right, not really. Well, would it improve security then? No. So is it for a browser compatibility? Absolutely not. So tell me, why is it always the same old story with you guys, wanting to refactor everything? I need to know. Because as devs, we know we've left messy code, we can't stop thinking about it. When we wake up in the morning, at lunchtime, in the evening, when we go home, and when we're trying to go to sleep, it haunts us. A lot of developers are very conscientious. It's just like, oh, that haunts me. Like, I know it could be better. I know there's something else I could do. And why is that? Because normally what we're doing when we're writing code is we're expressing an idea. Ideas are not stationary. Your understanding of ideas changes with time and experience. It could change 10 minutes after you wrote a piece of code. It could change 10 days after a piece of code, after somebody raised a question or you mentored somebody and you explained to them and you suddenly go, well, now my explanation makes this code look really stupid because there's a much easier way of doing it. But don't blame yourself because you couldn't have known. You're always in a learning process. We're always working with incomplete knowledge. So therefore, the whole point is that software is soft. Okay, we keep forgetting that. You're supposed to be able to change it. It's supposed to keep up with your current thinking. It's supposed to be a reflection of here's what we understand collectively as a team. The problem is most of what we understand appears to be what we understood 5 years ago, and we are fighting the past. So there are lots of definitions of architecture, so I'm going to get a bit poetic. Architecture is inhabited sculpture. I think this is a lovely way of looking at architecture just generally, but I think it also applies to our code bases. We often forget that when we talk about software architecture, we're often talking about the technologies, we're talking about the physical arrangement. That's the natural parallel for architecture. But we forget in software that the point of architecture is to live and work inside it. Buildings are not there merely to be structures, they are structures for people. Software architecture is for developers to live inside. And you can ask yourself, what is that experience like? Does it feel pleasant? Or do you feel like you're in a horror movie? Do you feel that instead, some people go, yeah, the code base is really nice. It's very habitable. It's nicely lit. There's some beautiful tests over there. I love the elegant code over here. My packages are all arranged like so. And it's just like, yeah, I feel I can get a coffee anywhere and just relax with the code and make changes. I feel comfortable and confident. On the other hand, you might be in a horror scenario. Yeah, you kind of go in. It's dark and dimly lit. There's some clanking somewhere and there's something dripping somewhere and it sounds like a child's scream in the distance. And I know that at least 3 developers have gone in and not come out yet. We're on a recruitment drive. So that's it. It's inhabited culture. What is it like to live in the code, that experience of being there? So where does refactoring fit in? Now, this is a quote I've heard attributed to many people. Michelangelo gets credited a lot with this one, but it's actually much more recent, George Pentecost. There is a beautiful angel in that block of marble, and I'm going to find it. All I have to do is knock off the outside pieces of marble and be very careful not to chisel into the angel with my chisel. This is, to some extent, the limits of refactoring in the real world, or creating a design in the real world. But guess what? In software is much softer. We can chisel into the angel and then put the pieces back, and it doesn't cost us anything. In software, we have time travel, which is kind of cool, okay? Oh, I'll undo that. I will revert to a previous version. Next time you are talking to your members of your family who want you to fix their computer. Say, no, I'm a time traveler. That is what I do for a living. I travel in virtual spaces. I travel through space and time. You want me to fix your computer? That's a hardware problem. That's the stuff of mortals, yeah? Okay, so this is a classic book published in '99. This is before refactoring tools became widely available. So what's the book about? Martin goes through a series of practices, and he shows you the intermediate steps that you need to take to change one thing from another, whether you are doing a rename, an extract method, extract class, whether you are adding parameters, removing parameters, whatever you're doing. He makes sure that you understand the steps involved if you are doing this manually. And a lot of people forget that that's in there. And it's a really important idea because he's trying to show you that refactoring is about a gradual change. Automated refactoring speeds that up, but it does it in those steps. But there's also something else here. This is at the time this book came out, this was not an accepted practice. The terminology of refactoring was relatively new. You know, Bill Opdyke was one of the people responsible for actually legitimizing it. This is also in the wave of extreme programming, so this is before the term agile was adopted. These ideas are coming out and actually saying this is a first-class idea, but most importantly, I want to refer you to the subtitle, Improving the Design of Existing Code. This is a design practice. And that's a really important point. Martin was not saying, here's ways of tidying up your code. Here's ways of managing technical debt. He was talking about the idea of improving the design. It's a design practice. He also offered a definition of what is refactoring. It is a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. Now, an important point about this is that it is based on making things easier to understand. It doesn't mean that what was there was wrong, it just means that our understanding has improved. And our understanding has improved for a number of reasons. Either, yeah, it was really bad, or it was really good, but the world has moved on, and now it looks kind of out of place. It solved a problem that we had, but you know, that 5-case switch statement didn't feel too bad, but now with 25 cases, I'm beginning to think I might have taken a wrong turn somewhere. It doesn't mean that the 5 cases was bad, it just means that 25 is no longer good. And that's the point, we're allowed to retake that decision. Now, if this were physical and logistical, I'd have to move stuff. I'd have to move rocks or, you know, stuff. Not in software. We don't have a logistics. There are a few laws of physics we have to respect, but most of them, we're time travelers, okay? And actually, the interesting thing about this is that the second edition, this is exactly the same definition. It has not changed. Without changing, there's a certain irony about that. So the text of this is identical in the second edition, which came out in 2019. And this one also still tells you the manual steps that you want to take, even though this lives in a world in which IDEs have made refactoring normal. The point is that Martin is still trying to get you to think. That's a really important thing going on here. Now, I mentioned Bill Opdyke. And I want you to kind of notice this. So refactoring object-oriented frameworks, this is his PhD. It was submitted in the early 90s. His work was from the late 80s to the early 90s. This is refactoring in its original form. His PhD supervisor is Ralph Johnson, okay, who is better known for the Gang of Four patents. Gamma, Helm, Johnson, Placides. That's that Johnson. And these guys, Ralph and colleagues, did a lot of work on refactorings, where a lot of this came from. And so for a lot of people, when they think about the story of refactoring, they think, oh, okay, that's available in tools that I use. But if you know a bit more history, you'll go, oh, but refactoring kind of grew up in the Java space. That's where it became the first-class thing. That's where IDEs started actually saying, this is normal, this is not an extra, this is not an add-on, this is not a plug-in, this is integrated. But many people there go, well, actually, it started in the Smalltalk community. That's Ralph Johnson and stuff. Actually, it didn't. This is in C++. The original language under which most of the research for refactoring was done in the late 80s, early 90s was C++. Ironically, the language that has perhaps received the least love in this department since. Bill Opdyke says the refactorings are defined to be behavior preserving. That kind of that phrase again, behavior preserving. So what do we mean by that? So let's talk about possibly the most overspecified abstract data type in the history of computing, the stack. Okay, I'm just going to focus on 4 operations. Stack is a vertical concept. Stacks don't have length. A stack is a vertical concept. So depending on your perspective, they either have depth or they have height. I tend to think of a push-down stack, therefore, and physically, most stacks, it's just like, yeah, it has a depth. You go from the top downwards. The language of top tells us that we're looking at something there. You can push things onto it, and you can pop things off. Now, I'm going to focus on this just being a strict pop. In other words, it doesn't return a value as a result. It just reduces the top. It just drops. Okay, so we're going to keep it really simple. My language of choice today is going to be JavaScript, for some reason. Maybe I didn't have enough coffee first thing. But there's an interesting thing here. Is this is a really what I'm going to do is I'm just going to simply use a very pure object form. JavaScript has many different object models. You can use a conventional class keyword, which was added in ECMAScript 6, 2015. Or you can use kind of classic prototyping model, or you can use the purest object model that it supports, which is that of a closure. Basically, I'm going to return effectively a record, a Cartesian product of operations. In other words, I'm going to offer you, here's a set of operations. That's a pure object. It doesn't have a type. It just is a set of operations. And I'm going to make my data private by it being local. This is the whole idea of block-structured programming, the idea that blocks are a unit of encapsulation. You don't need a private keyword. It's truly, truly private because it's inside a block. And that block outlives the life of the function from which it comes. And then I'm going to bind my operations to lambdas, which are bound to this private scope. And I'm going to implement it in terms of the built-in array, which does, in fact, conveniently enough, have push and pop operations. But I'm making mine a pure object model. It's purely method-based, and I'm going to wrap this. Okay? So I've got an implementation. It's all one-liners. That's nice. So, okay, that's great. We've just learned about object orientation. Where's the refactoring? Well, what about this? What I've done is I've just turned the underlying representation back to front. I've now decided that I'm going to use element 0 as the top instead of the last element, length -1. I have just changed the representation, and it will break no code because it is a refactoring. I have preserved the behavior. For an external observer, this is identical. Well, is it? Well, yes, we need to distinguish the term behavior, and that's something that the problem is the word behavior has too many meanings. And the way that Martin and Bill were using it was to imply just semantic behavior. But we need to distinguish different kinds of behavior. And it's also worth distinguishing the kinds of change that we make to code. Because this is also another thing. When we find people using the term refactoring, sometimes it suffers semantic diffusion. I've certainly encountered people who will sit there, and anything they're doing is refactoring. Oh, what are you doing? I'm refactoring. Oh, so what's the refactoring? It's a bug fix. Well, that's not a refactoring. The whole point of a bug fix is to change the observable behavior. It's broken. Now it's not. That's the purpose. Okay? So they use refactoring as a more fancy word for the word change. I am changing my code. Doesn't sound very technical. If you say refactoring, whoa, that's great. Okay? So I'm going to give you a simple kind of right-hand rule. I'm going to have to hold my left hand here. Oh, no. Amazing. Exchange. You see, I reversed the representation. Fantastic. So I've got a right-hand rule here. And these are not perfectly orthogonal. These genuinely aren't perfectly orthogonal. And neither are these. I want to focus on 3 different qualities that you might see in a piece of code. It's functional qualities. It's operational qualities. It's developmental qualities. The functional qualities are the semantics. That's the thing we normally talk about in unit tests. It's the how did the values change, how the values transformed, what events were raised. Okay? There's no question of timing and resources. Operational is how did it run? Did it run fast? Did it run slow? Did it use more or less memory? That stack changes in the way that it uses things. There's a time difference because we are using a different end, and therefore we are adding things. If we are appending versus prepending, there is a different performance, linear versus constant, amortized constant time. So there is a difference in that. That does not show up in the unit test. There is an operational change. Many refactorings will actually result in minor or major changes in performance characteristics, either for the better or for the worse, or they stay the same. Developmental qualities of the code is, well, how good is it? How habitable is it? How easy to change is it? So whenever you're making changes, if you think of these 3 axes, it clarifies things. Rather than just, I'm changing code, is what is my goal here? So when I add a feature, what is my goal in adding a feature? Well, it's to add more functionality. I am trying to take that axis and do more of it. We had this much functionality. Now I'm going to have this much functionality. after my change. What happens to the operational developmental axes? Well, maybe they stay the same. Maybe things get better, maybe things get worse. That's not, I mean, we'd always like things to get better, but the goal of feature addition, that's not their goal. Bug fixing kind of looks the same, except it works from a different perspective. With bug fixing, what you're doing is you are taking a deficit in functionality, okay? Instead of we have this much functionality and now you're going to have this, what is a bug? We promised you this much functionality, but you've got this. A bug is a shortfall. It's a deficit. If you want debt, that's a debt. You have a feature debt. That's what a bug is. We promised you this, you can't have it. Oh, you can do this, except it crashes everything. Oh, you can do this, except it munges your data in bad ways. Oh, okay, that's not what we want, so therefore we make up for it. But now we get to the interesting stuff. What about optimization? Optimization is a functionality-preserving transformation. By the way, that phrase, functionality-preserving transformation, drop that into conversation casually. It sounds good, okay? But that's what it is. You are preserving the semantics. The goal of optimization is to improve something on the operational axis and to maintain one of the other axes, the performance, the semantics, fixed. Because there's no virtue in saying, hey, look, it runs 10 times faster. Yeah, but it crashes every single time. But damn, it's a fast crash. That's not a virtue here, okay? The idea is you don't want to break things. So therefore, you keep one thing fixed whilst you improve the other. The wild card is what happens to the developmental quality. Sometimes an optimization will not necessarily add any complexity to the code. Sometimes it will add complexity to the code. A piece of code that uses caching is more complex than a piece of code that is not. Therefore, it is developmentally lower quality from the perception of the user. There's more cognitive load that I have to deal with. That's not necessarily a bad thing, but we have to understand that's a payment. On the other hand, sometimes some of the greatest performance improvements come through deleting code and simplifying things. It's just like, whoa, wait a minute, what's going on here? In fact, I mentioned caching. One of my clients had 4 levels of caching that they'd accumulated in a legacy code base over time. Every time they migrated platforms and stuff like that, it's just like, okay, oh, that went faster, but I think we can make it go even faster. They went faster because they moved to a different platform. The problem is optimizations are often based on a very delicate set of assumptions. If any of those change, then your optimization disappears. It turns out that rather than recheck the validity of the optimizations, they just accumulated them. When you deleted all of the caching, it ran significantly faster. Yeah, it turns out that none of it was an optimization and none of it was necessary anymore. But you still want the same semantic behavior. It's the time that changes. That's part of that axis. And then we hit refactoring, which is another functionality-preserving transformation, which is basically, my goal here is to improve something about the developmental quality, improve the habitability of the code, repay some technical debt. The act of refactoring is the opposite of technical neglect. It's actually technical care. What happens to the performance characteristics? Often it remains the same, but it may get a little bit worse, it may get a little bit better, but that's not the goal. So Martin also offers a definition of refactor as a verb. What does it mean to do it? Well, it means to restructure software by applying a refactoring. And interestingly enough, more importantly, Bill Opdyke's thesis was on automated refactoring. So this is over 30 years ago. Now, this is a book that I edited 2009, came out 2010. In fact, I recognize there are actually a few speakers who are represented here. In fact, I'd just say Norwegians are disproportionately represented in this book. But one of the guidelines from Dan Terhorst North was code in the language of the domain. And actually, the example that he uses here is, it's crowdsourced, but it's also an open source book. It's available on GitBooks. The example that Dan uses is actually a really good example of a number of things. Good abstraction, but also refactoring. If we look at this, what we are confronted by is something where all of the elements are well named. We don't need to do a rename because there's nothing wrong with the terminology. Portfolio IDs by trader ID. This is perfectly sensible. The get and contains key. That comes from the Java library on a map. Get ID, trader, portfolio. These are all good names. There's no names that I need to change. The only abbreviation there is actually a real-world abbreviation. ID is a real-world abbreviation, not a programmatic abbreviation. And yet it's not clear what's going on here. What we are missing actually is a name. We're naming an implied idea. It's not a rename, it's giving a name. Sometimes there's a missing name. What is this called? It doesn't want to comment. It wants to be abstracted. The semantic level at which we're working is, can this trader view this portfolio? This is to do with governance. This is to do with whether or not somebody is allowed to see something or not, because perhaps they are doing insider dealing if they can see it, and that's a bad thing. So what we've got here is a classic extract method, which you can do manually or you can do it automated. So last year, I kind of posted this. One of the great things about languages with modern IDE support is that thanks to refactoring tools, legacy code is a thing of the past. Along with older languages, developers never have to experience long methods, rambling classes, poor identifier names, or complex logic, or any of these things. Isn't it great that we live in an age where we don't have to tolerate these kinds of issue because we have tools that address them? I mean, you just sit there going like, particularly the older ones of you, you just say, I'm so relieved I don't have to deal with poorly named code anymore. It's such a great comfort to me that I don't open this up and find methods that are longer than one screen. I live in an age of joy, and for those of you who have no idea what it was like before, you're going, oh, I'm so glad I don't live in the dark ages. The only dark thing about my code is dark mode. I'm so relieved by this. That is what refactoring meant as we started getting tools that did this. I remember doing a talk for the Java user group, Javabin, here in Oslo in 2003 at the university. And somebody came up to me and he said, all these things you're talking about, Kevlin, we don't need to worry about them anymore because we have refactoring tools. And I kind of smiled at him. Yeah, the great thing, even then I was older than this guy. It's just, it's so sweet. You're so young. Had I had the benefit of foresight in Game of Thrones, I would have said, oh, my sweet summer child. Because that's not how this works. Yeah, some people missed the fact that I was joking in this original tweet and made comments, but Kevlin, we do have this. And that's the point. Why do we have this when we have the tools that solve the problem? Most things that people talk about in terms of unmanaged technical debt or technical neglect are solved problems. Most people experience and complain about and are experiencing on a day-to-day basis problems that have been solved. It's not like we don't know how to do this. When I entered the industry, I was having to deal with a Fortran legacy code base. We did not have any of the language or insights or any of this thing. I do not want to go back to that. I don't want to live in that past. And yet now I do. We produce a lot more code than we used to. So what happened? It turns out tools were never the problem. That's why I think it's so important that refactoring is not about your IDE. If your IDE doesn't have refactoring, that doesn't stop you. That was never the problem. Automation lowers the barrier to entry, but if you're not prepared to take it as an option, it turns out it's this. It's not the tools. It's our ability to understand and feel empowered to do it. That's the obstacle, and that's not toolable. So I just started, I kicked off this thread last year, as I just thought, actually, seriously, refactoring questions. What family of refactors do you find you use most, whether it's automated or not? You probably already in your head have an answer to this. You can probably think of the top 1, 2, maybe 3. But also, what are the ones that you're aware of that you think people don't use enough? What refactors do you feel are most overlooked or underutilized? Or it's by you or others? So the one, extract method, there was no surprise. Importantly, it's not the extract family, it's the extract method. Okay, that one is a really common one. Perhaps the most common one is rename. Okay, to the point that sometimes I find people doing a rename refactoring on something that only has one occurrence, like a test name. You don't need to refactor that. The whole point of a refactoring tool is it updates all references to things. So in other words, it's become so ingrained in people's fingers, they think of it as just even when they could just rename it there, they do a rename refactoring. But of course, there are limits to this. You can't rename everything. I don't want to give you the impression that you can just change everything. Software does have boundaries of hardness. It has publication boundaries. Observation from Josh Block, public APIs like diamonds are forever. Once you push something out to people that you don't influence or control, oh, good luck with changing that. And that, again, let's go back to 2003. I was dealing with a team in Germany, and one of their guys, again, had fallen in love with the refactoring tools. That's great. And he says, yeah, we're getting some real friction and real pushback from that team over there who are writing automated test tools for our code at the systems level. And they don't like the fact that we refactor. And I said, and yeah, they're real Luddites. They're holding us back. And I said, well, what's the problem? Well, you know, I'll just refactor and I'll change the name of something on an interface, or I'll delete an interface and stuff like that. And I said, so basically what you're doing is you're interrupting their workflow. Why should they be pleased with that? The point is that there is an inside and an outside to things. There is a boundary. You can't easily, once you go across a boundary, it's no longer a question of tooling and software engineering, it's social engineering. You are pissing that team off because they walk in and it's just like, oh, I've now got things to fix, whereas I didn't. You're creating work for other people. So I said, you know, you need to understand what the boundaries are. And you basically want a soft-centered suite. Okay? Whatever your boundaries, component, layer, whatever, class, you know, it's turtles all the way down. It's a very fractal thing, software. It's tougher on the outside and more stable than it is on the inside. This is really important. Otherwise, you end up with, you know, we can see the problem. You can't just refactor stuff. My favorite example is clonable. Okay? So clonable, you probably recognize this as an interface, or if you don't recognize clonable, that's in the JVM. If you're in the .NET space, iClonable. You developer. I hate that I prefix. We'll come back to that later. I understand people use it, but it is one of the dumbest things ever. I will demonstrate its dumbness and how it's anti-software engineering in a moment. But you're entitled to use it. You know, it's your choice. You just know you're doing something wrong. The point there is this one jumped the gene pool. It went from, and you know, lots of languages now have this. But here's the really interesting thing. I'm sure okay, so this is Norway, and most of you are Norwegians or learning Norwegian. And you get a new spelling convention, I don't know, every 5 years, which confuses the hell out of people. But every time a Dane comes to Norway, they go, oh, thank goodness, the spelling actually works. Okay? It's kind of vaguely phonetic. Even as an English speaker, I can kind of look at some Norwegian and go, yeah, I can kind of understand that. I don't have to figure out too much. It looks vaguely phonetic. English? No, not so much. But in as much, and sometimes people say English doesn't have a logical system of spelling. I'm really interested in language. I have bad news for you. The problem is not that English doesn't have a logical system of spelling. It's that English has about half a dozen logical systems of spelling, simultaneously, all in the same language, in the same word sometimes. I believe that's called competitive spirit. But in as much as there is a correct spelling of clonable, it doesn't have that first E. What happens if I wanted to refactor that? What happens if I'm Microsoft and I go, yeah, you know what, let's just refactor that? What happens if I'm Oracle and I want to refactor that? Then you just hear the sounds of systems breaking all around the world. That's what publication means. That's not your interface anymore, okay? You've given up control of it. However, I'd just like to point out that with great power comes great responsibility. Here is the Wiktionary entry on clonable. Alternative forms, especially in computing contexts. Well done, us. We have changed the spelling of a word through repeated misspelling. Repetition legitimizes. Repetition legitimizes. Repetition legitimizes. It makes it real. But what we learn from this is a simple guidance, that not all things are created equal. We must understand the boundaries. That what we want to do is we want to encourage the softness, that as much as possible, and this is not new advice, this is last century advice, don't publish interfaces prematurely. Modify your code ownership policies to smooth refactoring. There is a philosophy here. It's a design philosophy. What this also means goes against what some people think of as being a practice. Make code as open to modification as possible. Don't close your code to modification. Don't make your code extensible. These are bad practices. These are not good. If you are interested in agile development and keeping software soft, you make your code, as much of your code as modifiable as possible, you eliminate the possibility of extension that is not necessary. And when you discover it is necessary, you will have the knowledge to do it effectively rather than creating a debt. We can call this the closed open principle. So, what about the ones that people neglect? Extract class, really not very popular. This is why we end up with large classes. We're a lot happier to extract a method, but something about a class pushes it into pushes it across a boundary. It's like a surface tension issue. It's really, or an escape velocity. It's just like, oh, I'm not going to pull that into another class because that probably means I put it in another file, and that's another different thing in the version control system, and I'll have to, oh no, I'm not going to create a new file for that. That's too much. There's too much of an activation energy to get to that level. I'll just keep it here. You know, nobody will notice because the class is already 10,000 lines long. Nobody's going to notice another few lines. So, inlining, the opposite of extraction. Sometimes we want to do things that are the opposite. Simplify by actually removing an abstraction. Replacing things, deleting things. Oh, we're really bad at that. As I noted quite a while back now, we keep talking about incremental development. We don't talk enough about decremental development. There is a real skill in getting rid of the things that you don't want. Do we need this? No. Is there a simpler way of doing it? Yes. Is any other piece of code calling? No. Okay, get rid of it. That code is dead. You don't want it to come back to life when you're not expecting it. Zombie code is bad. It has cost the world billions of dollars. So there is a kind of philosophy that people normally think of in the context, language that we get from Lean, Kaizen, or given that it's Japanese, I will show you the hiragana. Kaizen in Japanese basically means just improvement, but in a business context, it has a very specific meaning, the idea of continuous improvement, the idea of like we're always doing, it's gradual. It's gradual. This is kind of like the every day you brush your teeth, you have a shower type thing. You don't save it up till the end of the month. Okay, you know, this is the way a lot of teams do refactoring. It's case like, I'm going to save time by not brushing my teeth and having a shower today. I will save it all up to the end of the month, and then I will spend the last Sunday of the month just brushing my teeth and having showers, and then I will see all those people who've been avoiding me for the last few weeks, which has been, honestly, a lot easier with working from home. But the point there is that this is the gradual stuff. It's the prevention of decay, or it's the gradual improvement. It's the we always do one good thing. Okay, just clean things up a little bit. And it's this progressive, stable, intermediate form that we're interested in. Each step that we go through is a good step. When you've refactored, what you've got may not be perfect, but it was better than what you had before. It's moving in a direction. You may not be at your destination yet. So, very simple example. Let's play around with words for a moment. Biquinary coded decimal. This is a fun word. It's a counting system of representing numbers based on counting in fives. I have no idea where that came from. With an additional indicator to show whether the count is in the first or the second 5, okay? So in other words, we break it down into tens, but then we have 2 groups of 5. And we can either be counting 1 to 5, 6 to 10, or 0 to 4, 5 to 9. And there are a number of systems that use this. Classic abacus systems, not the kinds you give to your kids, because that really messes with them. This kind of thing, okay? I remember as a kid seeing one of these and going like, this is really stupid. It only goes up to 7. It's like looking at a bike and going like, okay, there's 3 gears there and there's 5 gears there. My bike has 8 gears. No, that's not how it works. Biquinary, this is still used in some parts of the world, very effective, but it's a biquinary system. Okay, you have an upper register for low or upper 5, and then you have your 5. Very effective. It was actually used on early computers before we discovered the joy of just like, oh, sod it, just do it in binary. But we faked up a decimal system. And here we have the Colossus with human computers feeding the machine. But perhaps one of the classic number systems, a non-positional counting system, is the Roman numeral system. It's based on 5s. You probably never really thought about it like that. You just thought about it as a kind of bunch of letters, you know, that made you livid. But, you know, remembering the various letters. And this gives us a nice, really simple kata. So the kind of standard kata is, okay, I'm going to take a number, I'm going to take an integer, and I'm going to convert it into Roman numerals. I'm going to convert it into string form. Sure, fine, go ahead. And if you tackle this in a kind of enterprisey way, you'll end up with code like this. If you are being paid by the line of code, this is an absolutely fantastic way of doing it. It is needlessly imperative. It's all about state change. It's a lot of repetition. And I would generally say this is, I mean, I'm not saying there's anything wrong with doing this as your first cut solution. That's the whole point. If this is the way that you're programming it, go for it. There is nothing wrong with doing that. Remember, your software is soft, okay? You're not committing anything to anybody. You're not making a promise this is how it's going to be. You're just getting your thoughts out on paper. There's nothing wrong with writing this. There is a problem with checking it in, though, and saying, yep, I'm done. There is a problem with putting it in a book like this. This is the thing I was absolutely fascinated by. So I like looking into the history of programming. I think software development doesn't have a very long history, but it does have a history. And history is a vast early warning system of all the mistakes we're going to make again. And there is the classic quote, those who do not know history are destined to repeat it. There is also the counter quote, that those who do know history are destined to watch it being repeated. And Pascal was often held up as the language to learn. It's a good teaching language. I say I'm going to go against that. I said originally I did Fortran. When I saw Pascal, I thought this is fantastic. Now I have a bit more experience. Pascal is a crap language. I mean, you can try and argue that with me. The only people who ever argue that with me are people who use Object Pascal. I always point out, but Object Pascal is not Pascal. In the same way that Objective-C is not C and it's not Smalltalk. In the same way that C++ is not Smalltalk. In the same way that you pick a language, it's not whatever came before it. Object Pascal is not Pascal. It's a Pascal-based language. It fixes most of the problems. Not all of them, but most of them. But this is it. People held this up as an ideal. And here is one of the original books. And yet, right in there, that stuff on the right is exactly what I just showed you in Python a moment ago. It's just like, oh my God. It's because Pascal has weak abstraction mechanisms. Yeah, there I said it. It's bad for programming. It lacks the basic tools for data abstraction. It lacks the ability to factor out things appropriately. Let's look at the kind of factorings people do. So here is this structure. What are we going to do with it? We're going to refactor it. Okay, what's the advice on refactoring? Refactoring is about small changes. Everything works, always. It's about stable intermediate forms. It's like walking, okay? With walking, the definition of walking versus running is that walking means you maintain at least one point of contact with the ground at any point in time. It's always there. It's like 1, 2, 1, 2. Running is 0, 1, 0, 1. Maybe that's why developers like running, okay? But the problem is it's a less stable configuration. If you make a mistake, you fall. It hurts a lot more, okay? You may move faster, but you crash faster as well, and you're more likely to crash. The idea of refactoring is walking. It's gradual change. To support us, we value tests, we value automation, we value another pair of eyes. These are all ways of ensuring that we don't trip up, that every step is confidently placed. This, when we talk about stable intermediate forms, it's the idea of the intermediate form between here and there. Each step is stable. I can stop there and won't fall over. That's the idea. If you're in a sequence of refactoring, and that's the point, is refactoring is a plural, if you're in a sequence of them, you get interrupted, that's fine, it all still works. That's the idea. It's not like, okay, this is going to be a work of art. For the next 2 hours, I'm just going to put on the loudest rock on repeat on my headphones, and nobody better interrupt me, because otherwise the whole thing falls apart. I can't hold it in my head for longer than that. Refactoring is like, interrupt me at any point. I won't thank you for it, but I will recover from it. So we put some tests in. So here's some tests I've written in Python without a Python testing framework. It's based on a property-based testing style. It just basically checks that what we've got is meaningful stuff. I'm not expecting you to read this, but these are the tests that I use when messing about with this code, or these are the refactored tests I use when messing about with this code. And so we can take this. And what are we going to do? Well, what most people look at first is they see the recurrence. They see a repetition. They see that there is a grouping here, while, if, while, if, while, if, and then one more while for luck. There's always one left over. So in other words, what we can factor out, we can recognize that it's not just while, if. It's that there is another structure here, a numeric structure. It's a 10-something, 9-something, 5-something, 4-something, 1,900, 500, 400. Okay, 90, or 100, 90, 50, 40, 10, 9, 5, 4. There's a recurrence there. We've seen the repetition. We're cool. We're going to extract it. Not so fast. Extract method is one of the most popular techniques, but actually I'm going to say not always, but in most cases it's premature. Don't extract the method yet. The problem here is that you haven't looked enough at the control flow. People don't think about control flow enough. People think, oh, control flow, that's the thing you used to worry about in the 70s and 80s. No, it's the basic ingredient of a lot of software, particularly in imperative languages. Control flow matters. This is a control flow problem. You need to understand why we have while, if. And are there any other transformations you can make? Well, one of the most simple transformations is to recognize that in the limit, an if is like a while. An if is a thing that executes 0 or once. A while is a thing that executes 0 once or many. In the limit, some ifs can be replaced with a while. Not all. Please don't go into work and do that tomorrow. That would be really bad. Things will break. But sometimes, in the edge case, I can happily replace all of the ifs with the whiles. This is a degenerate case. In this case, it works perfectly. That's interesting, because what that actually means is that our unit of repetition is this. It's not the block of 10, 9, 5, 4. It's a single loop with 2 modifications. What we need to do is to extract the data structure. This problem is not a control flow problem, as it was first presented to us. The control flow was like squid ink. It clouded our judgment. You need to look through it and go, oh, this is a data structure problem. The control flow is trivial. Actually, it's the data model that's important here. Is this new advice? No, it isn't. In the Mythical Man Month, in the 2nd edition, oh, no, actually, I think it was even in the first, no, it was in the 1st edition. So in other words, this is something that Fred Brooks wrote in the 70s. Under the heading of representation is the essence of programming. He said, sometimes the strategic breakthrough will be a new algorithm. Much more often, strategic breakthrough will come from redoing the representation of the data or tables. This is where the heart of the program is. This is the soul of your code, is the data structure. It's not the control flow. And yet, because we don't understand the control flow, we don't see the hidden data structures. We end up with a very imperative style of programming. John von Neumann, in his Turing Award speech in 1977, published 78, he talked about, probably this is the longest Turing Award speech title of all. Can programming be liberated from the von Neumann style, a functional style and its algebra of programs? It's also one of the most technical presentations ever for a Turing Award speech. Notice he says style. The word paradigm was not yet used. You had to wait 1 more year before Robert Floyd won the Turing Award and introduced the world of programming to the word paradigm. Okay, Paradigms of Programming was his paper the following year. People were not using the word paradigm in software at all. So there is a kind of like a break point. 1978 onwards, people start using the word paradigm. Before that, it's just style. And he makes this observation. He said conventional programming languages are basically high-level complex versions of the von Neumann computer. Okay, von Neumann languages use variables to imitate storage. Control statements elaborate jump and test instructions. And assignment statements imitate fetching, storing, and arithmetic. Now, here's an interesting thing. I'm going to take an example to kind of exemplify the fact that we're really bad at understanding our own state change. Lots of people kind of say, oh, we're doing kind of functional stuff. And then I look at their code, and it's just like, no, you're not. You've just got a couple of immutable objects and a bit of link. It's kind of like functional sprinkling, but it doesn't make it functional. You've not paid attention to what are the changes. You keep modifying variables, and you have incredibly imperative control flow. Control flow has state. You can make control flow less stateless. I'll give you one piece of advice today. Remember that ifs have an else. For some reason, recently, I've even seen talks and blogs saying, I no longer use elses. And it's just like, great, when's your next blog? I use assembler. People have missed the message. Control flow has state. That's a really important thing. You can make your control flow less stateless by using else technology. I've just realized the branding. Let's call it a technology, and people will use it. Anyway, that's by the by. Okay, so I'm not expecting you to read this code, although, quite frankly, the size of this screen, you can probably read this. I want you to get an impression of this code. This code is from the Gilded Rose refactoring kata. If you've never tried this kata, it's good fun. It's a pure refactoring kata. It's not about, you do need to put some tests in, but it's not about adding new functionality. The goal of this is actually to refactor the code. And I like this because it actually looks a lot like control flow that I see in real code. It's very evolved. It's been around for a while. Nobody ever sat down to write it like this. It just got added and added and added. It's the process of accumulation coupled with a process of neglect. So we can see the structure there. What I'm going to do is I'm going to get rid of all the curly brackets. There is actually, by the way, as an aside, there is a strong case for going against one of the practices people now regard as good practice. Always put curly braces around your blocks. Actually, I go the other way. I challenge people to make everything single statement. There are a number of consequences of that, one of which is actually safer. But that's another talk. I'll just leave that one dangling there for you to go, I don't believe it. Kevlin just called the open-close principle crap, and he's telling us that curly brackets around blocks is not the way to go. If your language requires it, then of course you do it. I'm not asking that you don't compile your code. But I am saying you might be surprised. But that's another story. So I want to focus on the things that happen here. And when I talk about the things that happen, let me highlight in white all the places where there is state change. These are all the places where, all the places where we get some kind of modification of state. Yeah? So these are all places with state change. I'm going to narrow it. You don't need to know what this represents. But this looks like feature envy, item I.quality. If we look here, these are all the places that is modified, and here are all the places it is referred to. This is what is referred to as the feature envy smell. We are constantly, repeatingly going back to this, sometimes to check it, sometimes to modify it. It's like we can't leave it alone. It's just, oh, I want to change it. I want to look at it again. Maybe it's changed in the line. I need to. This immediately tells us that our control flow there's something wrong here. And in the worst case, this is the worst case scenario. This is the path where so item quality, we look at it 1, 2, 3, 4, 5, 6, 7, 8 times, or can I not count? It's 7, sorry, plus 1. So it's 7 times we look at it. And we modify it in 4 places. It's like, we can't leave it alone. It's bizarre. It's just like, what have we done that keeps causing us to reassign and recheck and reassign and recheck? So here's the refactored version. Now, one of the things I like about the Gilded Rose kata is that I find a lot of people, they do 2 things with one or 2 things that take them in the wrong direction when they do this. One of them is they look at this and they say, I'm going to extract method everywhere. Premature extract method actually prevents you from seeing the commonality. Sometimes you need to put, it's like tidying a room. You need to put everything in one place to see what's going on. Then you need to reclassify it. Don't pull it out based on your initial conceptions. You will prevent yourself seeing what's wrong. The other thing that people do is try and add an object model, which would be fine if it were an object-oriented problem. It's not an object-oriented problem, though. So anybody doing this with classes just creates more complexity. First of all, take it at the level at which it's presented. It's a control flow problem. How do I improve the control flow? Because we seem to be modifying and looking at everything. OK. This, if we flip the control flow, if we take an approach to control flow where we understand that what we are doing is effectively setting up some kind of pipeline and selection mechanism, then what you end up with, so let's resize this, drop the curlies. The ones in white, that's the only place state change happens now. There's no other state change here. The only other value being assigned, quality adjustment, that's not an assignment, that's an initialization. Okay? In other words, that value is an assign once. It's basically a constant. There is only one place where state change happens, and there is only one place where we look at item quality. And this is just the control flow refactoring. Take the code on the terms it presents you. Can I clean it up at that level? And then if you start saying, well, that's really funny. I've got a selection, and then I've got a response to it. At this point, it's just like, actually, it's a table lookup problem. It's a data-driven problem. It's a declarative problem. It's a table problem. But now I have lambdas hanging off. This is what I do in this case. I classify. So I basically end up with, here are the tables. This is how to find the right entry in the table. Tables, find the thing, do the thing. Tables, find the thing, do the thing. That's it. It's a table-driven problem. It's not an object-oriented problem. It's not even a control flow problem. But it was presented as a control flow problem. Now when I look at this, There's the state change that we had before, and there is the only point where we actually modify the quality. But now it's a lookup problem. Very, very different in that sense. And it's a reminder that this is what abstraction is about. It's not to be vague. It is to create a new semantic level in which we can be absolutely precise. If we go back to just a simple structure here, so this is not a lot of code. In all the examples I showed, they're not a lot of code. Sometimes we go, oh yeah, but we have a big system. How do you think you got a big system? You got a big system because all the small things became big. It turns out that, you know, I worked with a team a number of years ago, and we had this kind of like method that was about 8 lines long. And I said, what does this do? And everybody went, And it was just this tangle of logic and flags. So we worked on it. It came out as 1 line. Basically, it was return A does not equal B. It turns out you can make that quite complicated if you really try and put your mind to it. And that was the important point. The guys then said, yeah, but Kevlin, you've only saved us 7 lines. And I said, no, think about it another way. I've reduced this by a factor of 8. The funny thing is I had just made an estimate of their code base that was compatible with that. Their code base was about 1 million lines long. After working with them for a few weeks, I kind of got the feeling that it should be about 10 times smaller. I said, you have done in 1 million lines what other teams would do in 100,000. And that's because of the little habits. If you make everything 10 times longer, or 8 times longer, or 5 times longer than it should be, that's how you create big systems. So yes, the little stuff matters. Sweat it. It's important because that's how you, if you don't pay attention to that, that's how your systems get big and complicated. Now, you might say this is not the most complicated control flow, but we should get a heads up here. We're looking at this, and it's like suddenly we're doing integer-driven counting through a list. If you are working in a language that was invented after 1980, you have to think you're doing something wrong. Okay? If I am using an integer to count through, there's something wrong. And what am I actually doing? Well, initially, it's, yeah, I get a list. I've got a list of words. Then I sort it. That's good. That's nice and high level. And then I do all of this control flow. What's going on? This is a very stateful piece of control flow. So let me extract method. Okay? This is the block that's out of step. High level, take a copy of what we've got, the list of words. High level, sort. The next level down, the mechanics of eliminating adjacent duplicates. So therefore, we do an extract method. We remove duplicates. Now, this is C#. I can use extension methods. At this point, do a rename, because you're not really removing duplicates. You're removing adjacent duplicates. You're assuming that they are sorted. So our work here is done. Well, not quite, because we've got a new method. It's a bit tidier. It's well named, but we still have all of that code. Take a step back, and you think, if you're a C#, you think, oh, I know link. That's nice for you. I tend to find that pure link expressions in many cases are just ways of repeating the same word lots. Word, word, word. If you get that level of repetition in your link expression, try switching it to raw link. Much better. This is so this looks really good. Notice how different this is to the original control flow. How fundamentally different. I've reframed it. I've switched paradigm. What I'm looking at here is list of words, order by the word, and then make it unique. Now, there's an interesting thing. A lot of C-sharpers use link a lot. In fact, they use it too much because they don't know about data structures. I've seen some astonishing pieces of link. If you're using link, probably, I'm going to say half of what you need to do is there's probably already a method for it. Don't complicate things with additional link expressions. But more importantly, you may find there's an additional structure. The problem was sitting in front, the solution was sitting in front of us all of the time. Oh, you want a list of words that is unique and sorted. That's a data structure problem. That's not a processing problem. Okay? That's not a data flow problem. It's not a control flow problem. It turns out that the representation is actually the thing. Which leads us to another word that people often forget when they talk about process improvement. They talk about Kaizen. They don't talk about kaikaku. Kaikaku means radical change. It's also supposed to be, right, we're going to change something radical here. Now, people normally use this as the ways of working, but here I'm saying actually your design may change radically. It may look completely different to what you had before. So I'll kind of close with another example from 97 Things Every Programmer Should Know. Piece by Burke Hufnagel. I love this piece because, I mean, first of all, the title is great. It's also good advice on its own. You know, if you never do anything else, this is the, put the mouse down and step away from the keyboard. Yeah, you're stuck at the level, you're trying to solve a problem at the level you found it. You've got to take a break. You know, you're stuck. You clearly tried your best, but doing more of that's not going to help. You need to change your mind. Literally, you need to change your mood. Get up, go for a walk. If you've been standing, sit down. If you've been drinking coffee, drink herbal tea. If you've been drinking herbal tea, drink coffee. If you've been listening to loud rock, listen to something ambient or nothing. If you've been listening to ambient or nothing, put on loud rock. You need to change, because whatever it is that you are doing is not causing you to think in the way that is going to solve the problem. You've exhausted that level. And he shows this example, which is parsing a string that shows time in 12-hour format. Now, what is interesting about this is that, so this Java code, it's kind of like chiseling away, but not in a good angelic sense, chiseling away at a piece of code. This is what it looked like after he refactored it. God only knows what it was like beforehand. And notice there's a dot in here. Is that working today? No, that is not working. Oh, no. Sorry, that is working. This is the thing I want. There we go. There we go. Notice there is a dot there. There's a lot of this. And this is a brutal and imperative way of trying to solve the problem. Can I parse this bit? Bang! No! OK, it's not a number. OK, return, it's not a valid time string. And then, oh, wow, this is as procedural as it gets. So anyway, he stepped away from the keyboard, put the mouse down, went home. Next day, he says, wait a minute. This is a declarative problem. Why am I doing all this control flow? This is a declarative problem. Now, sometimes people joke, you know, hey, I had a problem, and I solved it with regular expressions. Now I have 2 problems, or star problems. But actually, in this case, what's great is that I can show somebody who doesn't know how to read regular expressions, and I can read it literally from left to right and explain. Oh, yeah, you take a 0 followed by 1 to 9, or a 1 followed by 0 to 2, then a colon, then the next group is 0 to 5 followed by... It literally reads from left to right. This is a nightmare by comparison. It doesn't matter if you know Java, this is a mess. If you don't know regexes, this is easy. That's the point. The problem was a different shape. It wasn't a gradual refactoring. So this tells us, this gives us a nice piece of advice, which we'll close on. Advice from Isabella Beaton, who is a figure in Victorian England, sadly died by the time she was 30, but she was known for writing a periodical and column collected together as the Book of Household Management. And you might think, well, I'm not running a Victorian household. Hey, you're working on a code base. That's like a Victorian household. But she gave us advice. She anticipated refactoring. She gave us the advice for refactoring. Software engineering advice from the 19th century. There is no work like early work. Clear as you go. Muddle makes more muddle. Not to wash plates and dishes soon after using makes more work. This is all the advice. This is everything you need to know. If we look at that as a cleanup, this is to avoid neglect, but more importantly, this is a proactive design approach. The observation from Herbert Simon, complex system will evolve more rapidly from simple systems, much more rapidly if there are stable intermediate forms than if there are not. Avoid the big bang changes, except when they are needed. The idea is progressively always be improving, the idea is that think of your design and development process as a search for design. Design is not a conclusion, it's a work in progress. You are constantly searching for it, and maybe there's something better over the horizon, but you embrace that as a possibility. If we are writing code, let us take the advice of the great authors of the 20th century. The only kind of writing is rewriting. Thank you very much.